Hello children, now let us solve previous year's JEE questions. First question, the coefficient of static friction between a wooden block of mass 0.5 kg and a vertical rough wall is 0.2. The magnitude of horizontal force that should be applied on the block to keep it adhere to the wall will be dash Newton. Take G is equal to 10 meter per second square. This question appeared in JEE Mains 2021. This is vertical wall and this is wooden block. A horizontal force F is applied on the wooden block to stop it from falling down. Mass of this block is given as 0.5 kg. Coefficient of static friction between the wall and the wooden block, μs, is given as 0.2. We have to calculate the value of F. This is FBD of the wooden block. Force F is applied on it in forward direction. N is the normal reaction applied by the wall on the wooden block. Mg is its weight that works vertically downwards at its geometrical center. Since this block has a tendency to fall down, so friction force on it will work vertically upwards. It is represented by Fs. At translational equilibrium, we will equate horizontal force with horizontal force and vertical force with vertical force. In other words, summation of Fx is equal to 0 and summation of Fy is equal to 0. So F is equal to N and Fs is equal to Mg. We know that Fs is less than or equal to μs into N. When Fs is equal to Fsm, Fsm is equal to μs into N. Putting the value Fs is equal to Mg and N is equal to F, we get Mg is equal to μs into F, or F is equal to Mg upon μs. Now we can put the values given. M is given as 0.5 kg, G we can take 10 meter per second square, μs is given as 0.2. So F comes out to be equal to 25 Newton. So the answer is 25 Newton. Second question, the length of a metal wire is L1 when the tension in it is T1 and L2 when tension is T2. The natural length of the wire is. These are the options given. This question appeared in JEE Mains 2021. Suppose this is the wire that is hanged from the ceiling. Its natural length is L. Now a mass M1 is tied to its other end so that this wire gets stretched and its length becomes L1. Tension in the wire is T1. Now another mass M2 is attached to its other end so that length of this wire becomes L2 and tension in it is T2. We have to calculate its natural length L. As per Hooke's law, F is equal to minus Kx, where x is amount of deformation and F is applied force on the wire. In first case, deformation is L1 minus L. So we can write T1 is equal to minus K into L1 minus L, where K is some constant. This is our first equation. Similarly, we can write T2 is equal to minus K into L2 minus L. This is second equation. Now divide equation 1 by equation 2. We get T1 by T2 is equal to L1 minus L upon L2 minus L. Now we can apply componendo and dividendo law. So T1 plus T2 upon T1 minus T2 is equal to L1 minus L plus L2 minus L divided by L1 minus L minus L2 plus L. So we can solve for L, which comes out to be equal to L1 T2 minus L2 T1 upon T2 minus T1. So the option B is correct. Third question, a block kept on a rough inclined plane as shown in the figure remains at rest up to a maximum force 2 Newton down the inclined plane. The maximum external force up the inclined plane that does not move the block is 10 Newton. The coefficient of the static friction between the block and the plane is. These are the options given. Take G is equal to 10 meter per second square. This is the figure given. This question appeared in JEE Mains 2019. We will consider two cases. Case 1, when 2 Newton force is applied on the block down the plane. And case 2, when 10 Newton force is applied on the block up the plane. This is FBD of the block in case 1. If the applied force is more than 2 Newton, this block will slide down. So friction force will work on this up the plane. It is represented by Fs1. N1 is normal reaction by the plane. Weight of this block is mg, that works perpendicularly downwards at its geometrical center. We will resolve this weight into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sin 30 and perpendicular to the plane component will be mg cos 30. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So along the plane equation will be Fs1 is equal to mg sin 30 plus 2. That is first equation. And perpendicular to the plane equation will be n1 is equal to mg cos 30. This is second equation. We know that Fs1 is equal to mu s into n1. Value of Fs1 and n1 we will put from here to get equation number 3. This is FBD of the block in case 2. If the applied force is more than 10 Newton, this block will move upwards. So friction force on it will work along the plane downwards. This is represented by Fs2. N2 is normal reaction applied by the plane. Mg is weight of the block. It is resolved into two components, one along the plane, another perpendicular to the plane. Along the plane component is mg sin 30 and perpendicular to the plane component is mg cos 30. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So along the plane equation will be Fs2 plus mg sin 30 is equal to 10. This is equation number 4. Perpendicular to the plane equation will be N2 is equal to mg cos 30. That is equation number 5. We know that Fs2 is equal to mu s into N2. Value of Fs2 and N2 we will put from here to get equation number 6. Now we can solve equation number 3 and equation number 6 to get value of mu s is equal to root 3 by 2. So the correct option is option B. Fourth question. A block of mass 5 kg is first pushed in case A and second pulled in case B by a force F is equal to 20 Newton, making an angle of 30 degree with the horizontal as shown in the figures. The coefficient of friction between the floor and the block is mu is equal to 0.2. The difference between the accelerations of the block in case B and case A will be. These are the options given. G is equal to 10 meter per second square. These are the figures given. This question appeared in JEE Mains 2019. This is FBD of the block in case A. We can resolve external force F along horizontal and vertical directions. Its horizontal component will be F cos 30 and vertical component will be F sin 30. Since this block is moving in forward direction, so friction force on it will work in opposite direction. It is represented by Fk1, that is kinetic friction. Weight of this block is mg, that will work vertically downwards at its geometrical center. N1 is normal reaction applied by the floor that will work vertically upwards. Vertical forces will counter each other and this block will accelerate in forward direction due to net force in forward direction. Let's say acceleration of this block is a1. So we can write equation of motion as m into a1 is equal to net force in forward direction and that is F cos 30 minus Fk1. This is first equation. Also n1 is equal to mg plus F sin 30. This is second equation. Fk1 is equal to mu k into n1. From equation 1 we can write a1 is equal to 1 by m into F cos 30 minus Fk1. Fk1 is equal to mu k into n1 and n1 is equal to F sin 30 plus mg. Now we can write value of sin 30 is equal to 1 by 2, value of cos 30 is equal to root 3 by 2, value of F is given as 20 Newton, mu k is given as 0.2, so A1 we will find out as 1 by 5 into root 3 F by 2 minus 0.1 F minus 10. Value of F we can put as 20 Newton to simplify it further. Let's say this is equation number 3. This is FBD of the block in case B. We can resolve external force F along horizontal and vertical directions. Its horizontal component will be F cos 30 and vertical component will be F sin 30. Since this block is moving in forward direction, so friction force on it will work in opposite direction. It is represented by Fk2, that is kinetic friction. Weight of this block is mg, that will work vertically downwards at its geometrical center. N2 is normal reaction applied by the floor. It will work vertically upwards. Vertical forces will counter each other, and this block will accelerate in forward direction due to net force in forward direction. Let's say acceleration of this block is A2. So we can write equation of motion as m into A2 is equal to net force in forward direction, and that is F cos 30 minus F2k. This is equation number 4. Also, N2 plus F sin 30 is equal to mg. That is equation number 5. We know that Fk2 is equal to mu k into N2. From equation 4, we can write A2 is equal to 1 by m into F cos 30 minus Fk2. Fk2 is equal to mu k into N2, and N2 is equal to mg minus F sin 30. So A2 is equal to 1 by m into F into cos 30. Value of cos 30 is root 3 by 2 minus mu k into mg minus F sin 30. Value of sin 30 is 1 by 2. We can put F as 20 Newton, m is given as 5 kg, g we can take 10 meter per second square. So A2 is equal to 1 by 5 into root 3 f by 2 minus 10 plus 0.1 f. This is equation number 6. We have to find out A2 minus A1, and that comes out to be equal to 0.8 meter per second square. So the correct option is option B. Fifth question, a boy pushes a box of mass 2 kg with a force F is equal to 20I plus 10J Newton on a frictionless surface. If the box was initially at rest, then dash meter is displacement along the x-axis after 10 seconds. This question was asked in JEE Mains 2021. F is equal to 20I plus 10J. That means Fx is equal to 20I and Fy is equal to 10J. Acceleration along x-axis is equal to Fx upon m. Magnitude of Fx is 20 Newton. M is given as 2 kg. So acceleration along x-axis is equal to 10I. We can calculate displacement of the box along the x-axis by applying second equation of motion in a straight line. X is equal to x0 plus v0t plus 1 by 2 ax into t square. Initial displacement was 0. Initial velocity is 0 as the box was at rest. Ax is equal to 10 meter per second square. T is given as 10 seconds. So x comes out to be equal to 500 meter, and that is the answer. So we will fill 500 here. Sixth question, a small block starts slipping down from a point B on an inclined plane AB, which is making an angle theta with the horizontal. Section BC is smooth and the remaining section CA is rough with a coefficient of friction mu. It is found that the block comes to rest as it reaches the bottom point A of the inclined plane. If BC is equal to 2AC, the coefficient of friction is given by mu is equal to k tan theta. The value of k is. This is the figure given. This question was asked in JEE Mains 2020. Section BC is smooth and section CA is rough. A block starts sliding down from point B. It starts accelerating till it reaches point C. Then between C to A, it decelerates due to friction force. Finally, at point A, it comes to rest. That means its velocity at A is 0. We will calculate coefficient of friction mu and then compare its value with mu is equal to k tan theta to get the value of k. Between section BC, let's say acceleration of the block is A1. mg is weight of the block that works vertically downwards at its geometrical center. Its component along the plane will be mg sin theta and perpendicular to the plane will be mg cos theta. N1 is normal reaction applied by the plane. We can write equation of motion as ma1 is equal to mg sin theta. This is equation number 1. And n1 is equal to mg cos theta. This is equation number 2. From equation 1, A1 is equal to g sine theta. Next, we will calculate the velocity of block at point C. Applying third equation of motion in a straight line, BC square is equal to VB square plus 2 into A1 into BC. VB is equal to 0 as the block was at rest at point B. So VC square is equal to 2g sine theta into BC. This is equation number 3. Between section CA, let's say acceleration of the block is A2. mg is weight of the block that works vertically downwards. Its component along the plane will be mg sine theta and perpendicular to the plane will be mg cos theta. N2 is normal reaction applied by the plane. Since this block is accelerating downwards, so friction force on it will work up the plane. It is represented by Fk. We can write equation of motion as ma2 is equal to mg sine theta minus Fk. This is equation number 4. And N2 is equal to mg cos theta. This is equation number 5. We know that Fk is equal to mu into N2. Putting these values of Fk and N2 in equation number 4, we get A2 is equal to g into sine theta minus mu cos theta. This is equation number 6. Next, we will calculate velocity of the block at point A, which is given as 0. Applying third equation of motion in a straight line, VA square is equal to VC square plus 2 into A2 into AC. VA is equal to 0, that is given. VC square is equal to 2g sine theta into BC. It is given that BC is equal to 2AC. So putting these values, we get 0 is equal to 2g AC into 3 sine theta minus mu cos theta. So either g is equal to 0 or AC is equal to 0 or 3 sine theta minus mu cos theta is equal to 0. Since g is not equal to 0 and AC is not equal to 0, so 3 sine theta minus mu cos theta is equal to 0, which gives mu is equal to 3 tan theta. Now compare this value of mu with mu is equal to k tan theta. So it gives the value of k as 3, which is our answer. Seventh question, a block of mass m slides on the wooden wedge, which in turn slides backward on the horizontal surface. The acceleration of the block with respect to the wedge is. These are the options given. Given small m is equal to 8 kg, capital M is equal to 16 kg, assume all the surfaces shown in the figure to be frictionless. This is the figure given. Small m is mass of the block, capital M is mass of the wedge. Angle of inclination of the plane is 30 degrees. This block accelerates downwards. This wedge accelerates backwards. This question appeared in JEE Mains 2021. Let's say acceleration of this block with respect to the wedge is A1. Acceleration of the wedge is A2. These two objects make a system. There is no external force applied on this system. As per Newton's second law of motion, F external is equal to m1 into A1 plus m2 into A2, where m1 and m2 are masses of two objects and A1 and A2 are their accelerations. F external is equal to 0. Let's say first object is this wedge. Its mass is capital M and its acceleration is A2. Second object is this block. Its mass is small m. And net acceleration on this block along this direction will be, actually there are two accelerations working on this. One A1 and another A2. So net acceleration in this direction will be A2 minus A1 cos theta. Now putting the values given. Capital M is given as 16 kg, small m is given as 8 kg, theta is equal to 30 degrees. So we get A2 is equal to root 3 by 6 A1. This is equation number 2. This is FBD of the block. mg is its weight. Component of weight along the plane will be mg sine theta and perpendicular to the plane will be mg cos theta. N is normal reaction applied by the plane. Net acceleration that will work along the plane, that is along the direction of motion, will be A1 minus A2 cos theta. So we can write equation of motion as m into A1 minus A2 cos theta is equal to mg sine theta. This is equation number 3. Now put the values of theta as 30 degrees and A2 is equal to root 3 by 6 A1. we get value of A1 as 2g by 3. This is our answer. So the correct option is option D. Eighth question, two blocks A and B of masses Ma is equal to 1 kg and Mb is equal to 3 kg are kept on the table as shown in the figure. The coefficient of friction between A and B is 0.2 and between B and the surface of the table is also 0.2. The maximum force F that can be applied on B horizontally so that the block A does not slide over the block B is dash Newton. These are the options given. Take G is equal to 10 meter per second square. This is the figure given. This question appeared in JEE Mains 2019. First step is to find out direction and magnitude of friction forces. There is no external force applied on block A. Still, it will move in forward direction along with block B due to friction force only. So, friction force will work on block A in forward direction on its lower surface, which is in contact with block B. An equal and opposite friction force will work on upper surface of block B as they make action-reaction pair. Table will apply friction force on lower surface of block B in opposite direction to the applied force F. Now we know the directions of friction forces. Next, we will calculate magnitude of friction forces. Fs1 is less than or equal to mu s1 into n1 and n1 is equal to ma into g. So Fs1 is less than or equal to mu s1 into ma into g. Value of mu s1 is given as 0.2. Ma is equal to 1 kg and g is given as 10 meter per second square. So Fs1 is less than or equal to 2 Newton. Fs2 is less than or equal to mu s2 into n2 and n2 is equal to mb into g. So Fs2 is less than or equal to mu s2 into mb into g. Value of mu s2 is given as 0.2. mb is equal to 3 kg and g is equal to 10 meter per second square. So Fs2 is less than or equal to 6 Newton. Second step, calculate maximum acceleration of block A which is moving due to friction force only. AA max is equal to F1Sm upon Ma. Value of F1Sm is equal to 2 Newton and Ma is equal to 1 kg. So AA max is equal to 2 meter per second square. When the value of external force is more than 6 Newton, block B will start sliding on the table, taking block A along with it, till their acceleration reaches 2 meter per second square. Till that point, we can treat them as a single body on which external force F is applied. So their acceleration AA is equal to AB is equal to F minus Fk2 upon Ma plus Mb. Value of Fk2 is equal to Fs1 plus Fs2, that is 8 Newton. So F comes out to be equal to 16 Newton, that is maximum external force is 16 Newton when block A will not start slipping over block B or block A will go along with block B. So our answer is 16 Newton. And the correct option is option A. Ninth question, an inclined plane is bent in such a way that the vertical cross section is given by y is equal to x square by 4, where y is in vertical and x is in horizontal direction. If the upper surface of this curved plane is rough with coefficient of friction mu is equal to 0.5, the maximum height in centimeter at which a stationary block will not slip downward is dash centimeter. This question was asked in JEE Mains 2021. We know that y is equal to x square by 4 is the equation of parabola. So this plane is parabolic. Its inner surface is rough. We have to find out maximum height at which a block is kept so that it doesn't slip downwards. This is a BD of the block. This line is tangent at point P. Let's say tangent makes an angle theta with the positive x-axis. Mg is weight of the block that works vertically downwards at its geometrical center. We will resolve Mg into two components. One along the tangent, another perpendicular to the tangent. Along the tangent component will be mg sine theta, and perpendicular to the tangent component will be mg cos theta. Since this block has tendency to slip down, so friction force on it will work up the plane along the tangent. It is represented by Fs. N is the normal reaction applied by the plane, which works perpendicular to the tangent. At translational equilibrium, we will equate forces along the tangent and perpendicular to the tangent separately. So we can say that Fs is equal to mg sine theta, this is equation number 1, and N is equal to mg cos theta, this is equation number 2. We know that Fs is equal to mu into N. So mg sine theta is equal to mu into mg cos theta, or mu is equal to tan theta. This is equation number 3. Equation of the plane is given by y is equal to x square by 4. So if we find dy by dx, that will represent slope of this tangent, and that is equal to tan theta. So dy by dx is equal to x by 2, or tan theta is equal to x by 2. This is equation number 4. From equation 3, tan theta is equal to mu. So mu is equal to x by 2, or x is equal to 2 mu. Value of mu is given as 0.5. So x is equal to 1 meter. Now we will put the value of x in this equation. So value of y comes out to be equal to 1 by 4 meter, or 25 centimeter. So this is our answer because h is equal to y. So h is equal to 25 centimeter is the answer. Last question. A block is moving on an inclined plane making an angle 45 degree with horizontal, and the coefficient of friction is mu. The force required to just push it up is 3 times the force required to just prevent it from sliding down. If we define n is equal to 10 mu, then n is. This question appeared in JEE Advanced 2011. We will consider given two cases one by one. In case 1, force F1 is applied on the block to push it up the plane. In case 2, force F2 is applied on the block to prevent it from sliding down. This is FBD of the block in case 1. Force F1 is applied on the block to push it up the plane. Since the block will move up the plane, so friction force on it will work down the plane. This is represented by Fs1. Weight of the block is mg, that works vertically downwards at its geometrical center. We will resolve it into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sine 45, and perpendicular to the plane component will be mg cos 45. N1 is normal reaction applied by the plane which is perpendicular to the plane. At translational equilibrium, we will equate forces along the plane and perpendicular to the plane. So F1 is equal to mg sine 45 plus Fs1. This is equation number 1. And N1 is equal to mg cos 45. This is equation number 2. We know that Fs1 is equal to mu s into N1. From equation 1, F1 is equal to mg sine 45 plus Fs1. Put Fs1 is equal to mu s into N1, and N1 is equal to mg cos 45. So we get F1 is equal to 1 by root 2 mg 1 plus mu. This is equation number 3. This is FBD of the block in case 2. Force F2 is applied on the block to prevent it from sliding down. Since the block has tendency to slide down, so friction force on it will work up the plane. It is represented by Fs2. Weight of the block is mg, that works vertically downwards at its geometrical center. We will resolve it into two components, one along the plane, another perpendicular to the plane. Along the plane component will be mg sine 45, and perpendicular to the plane component will be mg cos 45. N2 is normal reaction applied by the plane, which will work perpendicular to the plane. Now at translational equilibrium, we will equate forces along the plane and perpendicular to the plane separately. So we can say that F2 plus Fs2 is equal to mg sine 45. This is equation number 4. And N2 is equal to mg cos 45. This is equation number 5. We know that Fs2 is equal to mu s into N2. From equation number 4, F2 is equal to mg sine 45 minus Fs2. And Fs2 is equal to mu s into N2. N2 is equal to mg cos 45. So we get F2 is equal to 1 by root 2 mg into 1 minus mu. This is equation number 6. It is given that F1 is equal to 3F2. When we put this value, we get 1 plus mu upon 1 minus mu is equal to 3. Now we can apply componendo and dividendo law to get the value of mu. So 1 plus mu plus 1 minus mu upon 1 plus mu minus 1 plus mu is equal to 3 plus 1 upon 3 minus 1. So we get the value of mu is equal to 1 by 2. It is given that n is equal to 10 mu. So n is equal to 10 into value of mu is 1 by 2. So n comes out to be equal to 5. So this is the answer. In next video, we will start chapter number 5, and that is work, energy and power. If you have a question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.